This is Algebra 1, Lesson 8.3, Division Properties of Exponents. Today we are using division properties of exponents to evaluate powers and simplify expressions, and then we're using those same properties to find probability, beginning on page 463 in the textbook. First thing we have is division properties of exponents. Let A and B be numbers and M and N be integers. So we're not talking about fractions. Quotient of powers property says to divide powers having the same base, subtract the exponents. Remember when we did multiplying to the same base, you added the exponents. This is division of the same base. You're going to subtract the exponents. So you have A divided by A to the M divided by A to the N. So you do A to the M minus N, where A can't be equal to 0. All that is, when you divide the same base, you subtract M and N. So the example used with numbers instead is 3 to the 7th divided by 3 to the 5th. So you have the same base. Both of them are 3 and 3. So you subtract 7 minus 5, which gives you 3 squared. And if we went further than that, it would come out to be 9. So that's the quotient of powers property. If they're dividing, you subtract the exponents. Just like if they're multiplying, you add the exponents. The power of a quotient property says to find a power of a quotient, find the power of the numerator and the power of the denominator and divide. So just like we had A times B to the M, we knew to make sure to have A be raised to the M and B be raised to the M. We're going to do the same thing with this, except now it is a fraction. It says A over B to the M. So you're going to have A raised to the M power and B raised to the M power. So A to the M divided by B to the M, again, where B cannot be equal to 0, since you can't have 0 at the bottom of a fraction. The numbers that are going to be used are 4 to the 5th, 4 over 5 to the 3rd. Raise 4 to the 3rd and 5 to the 3rd. 4 to the 3rd over 5 to the 3rd. 4 to the 3rd we know is 4 times 4 times 4. 5 to the 3rd is 5 times 5 times 5. So we go further than that. But again, this is the power of a quotient property, telling you to raise both the numerator and the denominator to the exponent. Here's example number 1, using the quotient of powers property. 8 to the 4th divided by 8 to the 3rd. Same base, both of them are 8. You subtract the exponents, 4 minus 3. What that gives you is 4 minus 3 is 8 to the first power. Anything to the first power is just whatever it is, 8. Now for C, it says 5 to the 3rd times 5 over 5 to the 5th. What you have to make sure to do is, the first thing you're doing is you're doing what's at the top of the fraction. This is 5 to the first power. That's the thing people will forget, that there's a 1 that goes there. You're multiplying the same bases. Both of them are 5. So you add 5 to the 3 plus 1, which gives you 5 to the 4th. Over 5 to the 5th. So now you have the same bases. Both of them, again, are 5, and they're dividing. So just like a minute ago, you're dividing the same bases. You subtract the exponents. It becomes 5 to the 4 minus 5. Don't put the larger number first. Put the number that's at the top first. That gives you 5 to the negative 1. Remember, nothing could be a negative exponent. So it's 5 to the negative 1 over 1. Remember, since it's a negative exponent, just have it ride the elevator and go down. 1 stays at the top, and it becomes over 5. Because it's 5 to the first power, positive on the bottom. B says negative 7 to the 5th divided by negative 7 to the 5th. Same basis, both of them are negative 7. So subtract the exponents 5 and 5. You get negative 7 to the 0 power. We know anything to the 0 power is 1. 1 over x to the 7th times x to the 4th. Remember, everything is considered to be over 1. So if you multiply straight across, you would get 1 times x to the fourth, which is x to the fourth, and x to the 7 times 1, which is x to the 7. Now you have the same bases. They're dividing by each other. Subtract the exponents 4 and 7. X to the 4 minus 7 is going to give you x to the negative third. Again, elevator rule. You can't leave a negative exponent. X to the negative third, everything's over 1. Ride the elevator down, and when it goes down, it becomes positive third. So it becomes 1 over x to the positive third. On the back, do this problem. 4 to the fifth over 4 to the fourth. Okay, you're dividing the same bases. Both of them are 4. So you subtract the exponents. 5 minus 4, which is 4 to the first power. We know that that simply means 4. Do this one. Negative 3 to the fourth divided by negative 3 to the fourth. Again, you are dividing the same bases, negative 3 and negative 3. So it's negative 3 to the 4 minus 4. Division means to subtract the exponents. Negative 3 to the 0 power, anything to the 0 power is 1. This one. Okay, we got 6 to the third times 6 to the fifth divided by 6 to the ninth. Do this part first. Same basis, 6 and 6. So add the exponents. 3 plus 5 gives you 6 to the eighth over this part, 6 to the ninth. Now you have the same basis dividing by each other. Subtract them. 6 to the 8 minus 9 we know is 6 to the negative 1. We can't leave it like that. Remember, anytime something has a negative exponent, have it ride the elevator. So it goes down and becomes 1 over 6 to the positive 1, which is simply 1 over 6. And do this last one. Everything is over 1 when you multiply straight across. 2 times x squared is going to be 2x squared. 4, x to the fourth times 1 is x to the fourth. So we have 2 on top, but that's not going to change what we do with our exponents. It's still the same exponent dividing the same base, x and x. So it'll be 2x squared minus 4. Remember, division pairs with subtraction. That gives you 2x to the negative 2. Now pay attention to this part. Only x is being raised to the negative exponent, not 2. Therefore, 2 is going to stay on top, and x is going to ride the elevator down and become to the positive 2. 2 over x squared. Example number 2 is using the power of a quotient property. This is a negative in front if you missed that. Negative 8 over 5 to the negative third. This is being raised to the negative third. So negative 8, all it this step does is puts the negative there for you. But this is being raised to the negative third, and this is being raised to the negative third. So negative 8 to the negative third over 5 to the negative third. Notice right here it says the definition of negative exponents. What it does from this step to this one is it flips it. Since it's a negative, remember, it rides the elevator. This goes down, this comes up. Notice on the next line, 5 to the third positive is at the top now. The denominator became the numerator. And negative 8 to the negative third is now on the bottom, and it's to the positive third. So 5 to the third is 125 over negative 8 to the third is negative 512. And right here, they just put the negative back in the front. But negative 125 over 512. Do this one. 1 over 4 to the third power. Okay, 1 gets raised to the third power, and 4 gets raised to the third power. It doesn't matter how many times you raise 1 to a power, it's going to remain 1. 4 to the third, 4 times 4 is 16, times 4 is 64 for that one. What about this one? You have negative 4 over x squared. Remember, before you do multiplication, before you do this negative 1 times that, you got to do the exponents according to your order of operations. So make sure 4 gets raised to the second power and x gets raised to the second power. Again, before you do this, times that. 4 squared, we know is 16 over x squared, and then we'll times it by this negative 1. So it'll become negative 16 over x squared. Do this last one. Again, just like the others, this one's getting raised to the negative 4, so 3 to the negative 4th, and this one is getting raised to the negative 4, 2 to the negative 4. Both of them are raised to the exponent. Since both of those are negative, they're both going to ride the elevator. This is going to go down, this is going to go up. So on the bottom, you have 3 to the 4th. On the top, you have 2 to the 4th. 2 times 2 is 4, times 2 is 8, times 2 is 16. And 3 to the 4th, 3 times 3 is 9, times 3 is 27, times 3 is 81. 16 over 81. Example number 3 is simplifying expressions. Now you're putting a lot of stuff together. You're putting multiplying bases and adding exponents together. You're putting dividing bases and subtracting exponents together, and you're raising powers to powers. So you have 3x to the 4th over 3xy to the 4th over 4x to the 3rd times 12x to the 3rd y squared over x squared. First thing you do is multiply them straight across. 3 times 12 is what we're going to get first. That's 36. Then you have x to the first power times x to the third power. You add the exponents. X to the 1 plus 3 will be x to the 4th. Then you have y to the 4th times y squared. You add those. 4 plus 2 to get y to the 6th. So the top, 36, x to the 4th, y to the 6th. Then multiply straight across again. 4 times 1, it's not shown. I'll simply say 4. Then you multiply in the same base as x and x again. You add 3 plus 2 to get x to the 5th. So now do your quotient of powers. 36 divided by 4 will give us 9. And you have the same bases, x and x, that are dividing by each other. Same bases means to subtract 4 minus 5. So 36, you're going to have 36 divided by 4 is going to be 9. X to the 4 minus 5. Y to the 6. I don't think they have that step written. What that gives you is 9x to the negative 1 power, y to the 6th. Remember, you can't leave something raised to a negative exponent like that. That has to ride the elevator. 9 is not being raised to a power. X is the only thing being raised to a negative power, so it's going to go down. 9 is going to stay on top. Y to the 6th is going to stay on top, and x is going to go down to the bottom. 9y to the 6th over x. And that's all you can do with that. You don't take 6 and subtract 1 from it because y and x are different bases. The other problem says 2x squared over y cubed to the 5th. First thing you want to do is make sure everything gets raised to the 5th power. Okay, so raise the top to the 5th power and the bottom to the 5th power. 2 to the 5th, just like the bell work, x squared to the 5th. Multiply the exponents when you raise a power to a power. So it'll be 2 times 5, and it'll be 2 to the 5th. Same thing with this one. Y to the 3rd to the 5th is going to be y to the 3 times 5. So when we do that, we get 2 to the 5th times x squared times 5, and y to the 3 times 5. 2 to the 5th, we know is 32. X to the 2 times 5 is x to the 10th. Y to the 3 times 5 is y to the 15th. 32, x to the 10th, y to the 15th. Again, you don't subtract 10 and 15 at the bottom because they are different bases. They are not the same, x and y. Simplify this one on the back. 12x to the 3rd y over 4x. I said 12. I meant 3x to the 3rd y over 4x times, there's the 12, x squared y squared over y to the 3rd. First things first, go straight across. 3 times 12, we know it's going to be 36. X to the 3rd times x squared. That's x to the 3 plus 2. Y to the 1st power times y squared. That's y to the 1 plus 2. On the bottom, 4 times, if there's a 1 there, will be 4. X, y to the 3rd. So clean up the top. 36. X to the 3 plus 2 is x to the 5th. Y to the 1 plus 2 is y to the 3rd over 4 x y to the 3rd. Divide 36 and 4. You know you're going to get the number 9. Then you're dividing the same bases, x and x. That's x to the 1st power at the bottom. Since you're dividing the same bases, you subtract the exponents. 5 minus 1. Oh, it's going to be x to the 5 minus 1, excuse me. X to the 5 minus 1. Same thing with your y's. Y and y is going to be 3 minus 3. That's going to be 9. That'll be 9 to the x, 9x to the 4th, y to the 0, there's no reason to write anything y to the 0 because it becomes 1. 9 x to the 4th is the simplified answer for that one. And then do this last one. Okay, so make sure we don't run out of time. Everything gets cubed. 3 gets cubed. X squared gets cubed. That means 2 times 3. And y gets cubed. 3 to the 3rd power is going to be 27. X to the 2 times 3 is to the 6th. Y to the 3rd. You don't subtract 6 and 3 because 1 is x and 1 is y. 27 x to the 6th, y to the 3rd.